Welcome to this talk. I'm Chet Haase.
And I'm Romaine.
And today we're going to be giving a presentation on ISO 9000.4.1 Specification of Quality Management Process.
You should not be excited about this kind of title.
In the specific realm of computer software. Thank you for the interruption. We decided, after we came up with the accurate title for the talk, that the acronym was insufficient. So
we tried a different acronym, or quality, and it stands for quick uptake and like history. Yup. But that wasn't great either.
So we thought, what if we went the Steve Ballmer route and said quality, 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 quality.
The acronym for that is Q14.
Someone on the team pointed out, in fact, there's 15 of them, so there's a little quality problem. We're going to cover several aspects of quality today. Here's the rough agenda. First of all, we'd like to talk about ourselves for a while. We need to define what we mean by quality. We need to define what you mean by quality.
Then we'll have an equation, because it makes us look smart, having a bunch of Greek letters on screen.
We're going to give you some metrics, charts, and data, because that's how you prove things.
Then we're going to talk about some misconceptions you might have about how to achieve quality in your group.
And I think probably the most important thing to the people in this room is how can you achieve quality in your organization?
And finally, you will have questions for us, and maybe we'll have answers. But first, the most important part, Chet.
So let me talk about myself a little bit. I run a company called Quality Consultants Incorporated. I am the president, founder, owner, CTO, CEO, and chairman. I am also a consultant. I've been doing engineering for many years, and during those many years, I have created many bugs. However, from the year 2015 to now, I have been focusing exclusively on presenting about quality, during which time I've created 0 bugs. Also, I have a certificate of quality, which was awarded this year. We'll get back to that later. I want to re-emphasize 0.
I'm Romain. I work for Quality Consultants Incorporated. I am the Chief Quality Officer, I'm also the Quantitative Quality Quack, or Cuckoo Quack. And I am the only employee so far. Unlike Chet, I have no experience in engineering, which means I have also created 0 bugs. I also got my certificate this year, and I want to emphasize 0 bugs.
So let me return back to the important point that we talked about, a certificate of quality. As I said, this was awarded this year, if you look closely in the lower left corner, but I want to draw your attention to a couple of important things here. One is that it says quality not once, but twice. Also, it says my name. And then finally, up in the upper right, I want to draw your attention to the level of quality on this certificate. That's pretty amazing.
After Chet got his certificate, I wanted my own, and I was able to get one. So now we're the same.
All right, so what do people mean by quality? Well, I like to break words down into their Latin roots because there's no better way to understand the meaning of words than to define it through dead languages. If we look at qual, it obviously means what? It obviously means IT. And why obviously means why, which if you put it all together means what? IT, why? I think that's pretty obvious, but Romain disagreed.
I was not entirely satisfied with this definition, and I've been studying French for a few years, so I decided to look at the word quality in French and look at the roots. So we have K, which means only, Li, which stands for bed, and Y, which means there. So only, bed, there. And in the words of a famous French writer, when the product is so bad, one can only sleep.
We think that Voltaire probably said this. We're not sure, it doesn't matter.
We found another quote about quality. Anyone know what it means? We are asking because we don't know.
Nor can we pronounce it, so we'll just leave it there for you to read. The person who came up with this quote is irrelevant. All right, so that's what people mean by quality, but what do we mean by quality? Do we mean tests, is it important to have things like a load test or any of the myriad of other tests that we have in software organizations?
So raise your hands if you think that tests are important for quality.
Okay.
Right, you're
Pretty
right.
good,
Yes.
pretty good. Well done. Well done. Everybody else is wrong. All right.
How about quality metrics? For instance, here are metrics that we've used on the project recently. We discovered that when the number of defects go down, the quality goes up. So who thinks here that metrics are important? Raise your hand if you think metrics matter.
All right.
Not as many people.
No.
Well, those who raise their hands, you are right.
All right. How about eliminating bugs? What about taking those defects and getting rid of them? Is that what we mean by quality?
Those are features, not
They-
bugs.
Okay, you could reinterpret defects as features, especially around performance review time. But in general, let's assume that you do have errors in the product. What about eliminating them? Is that what we mean by quality? Good guess, and you're wrong. One of my favorite quotes is this one. It says, "Quality software has no bugs to eliminate." It's one of my favorite quotes because it's mine. So just the fact that you're working on a piece of software that had bugs to begin with means you're not working with quality software. So that's not what we're going for here.
But we can define quality using an equation. So it's the equivalence theorem of code, or ETSI. And it goes like this. The number of bugs equals the number of lines times
The number of files
times the number of statements.
times the number of conditions.
And then we square it because a lot of equations do that.
It's important to take the summation of values in any math formula, really.
And we sum from 0 to infinity using the variable x. Again, it seems to be what math people do, so we did that as well. And we are software engineers. Engineering is not rocket science. It's not real engineering. So we have this error term that goes from minus infinity to plus infinity.
And using that equation, you can calculate the exact level of bugginess of your code, which it directly affects the level of quality. All right, so now let's get into metrics. Obviously, you need charts and data, so let's take a look at some important ones. So where do the bugs live in the organization and the product? Do they live in the documentation?
No, they don't. Do they live in the
They
specification?
do not. How about memos that people send around the offices?
Never seen bugs in memos. Emails?
Not really, no. But what about the desk drawers?
I have seen bugs in desk drawers, different type of bugs.
How about the monitors, people's displays? Is that where the bugs?
Same answer.
Conversations that people have, meetings that they have with each other.
Not really.
Turns out all the bugs live in the code. All right? Keep that in the back of your mind. We'll come back to it. Now, who actually creates the bugs? Is it the people in the sales organization or marketing?
No, it's not the barista, it's not the security guard.
How about the people that clean the offices?
But on a recent project, we discovered that management sometimes creates bugs. And this was a particular case of a manager who used to be an engineer, and they thought they could still write code. And they did, which led to bugs.
But for the most part, all of the bugs are created by the engineers in the organization. All right? So this is how we've done studies with all of our clients. This is how you relate code with bugs in a product. As the amount of code goes up, and you can believe this data because it's in a chart, the number of bugs also goes up. Right? They are lockstep, except for, if you'll note, this one situation down here.
Yeah, so this was the case of an engineer who decided to delete a bunch of code, which led to a large number of bugs. So we solved the problem. We deleted the engineer, we put the code back, and the number of bugs went back where it should be on the chart.
All right,
So yeah, what do we want? Obviously, to achieve quality, we want to reduce the number of codes. And thanks to the previous chart, we know that we need to reduce the amount of code.
all right. So we'll see how to get back to that later. In the meantime, we want to talk about misconceptions. These are things that probably everybody in the room, except us, thinks about quality. So we call this believable solutions or BS.
So the first one, and I'm sorry if you already know about that one, the Guidelines and Ground Rules of Methodology Excellence, or GAGME. So it's a process that goes like this. You first identify the processes at your company. You document approaches to apply those processes. You form teams to discuss methodology to make sure you can implement the processes the right way. And you present findings to the team, you train the team based on the guidelines that came out of the findings, and finally, engineers write code. So if we look at where bugs are created in the process, bugs never happen in the first steps. But when we reach the last one, that's where bugs happen. So this won't work.
But the next one, better specifications, also coincidentally known as BS. You comprehensively itemize the requirements in a product, you identify the problems ahead of time, you propose solutions, and then engineers write the code. And similarly with this one, none of the problems happen with the process, all of the bugs are created in the code.
And I think you're starting to see where the problem lies. Another one, the code review approval process, or CRAP. And the way you think it usually works. So engineer A writes code, hands it over to engineer B, who reviews and suggests changes. Here. Engineer A fixes the bugs and submits the bug-free code. So where do we have bugs? When we write the code, bugs never happen, obviously. When we review the code, when we fix the bugs are gone. And when we submit, the bugs are still gone. Unfortunately, that's not what happens in real life. This is what really happens. Engineer A writes code, we have bugs. Then we have the code review, no bugs there. But then engineer A writes more code to address the code review, and we have more bugs. And finally, we submit the buggy code. The bugs remain.
All right, here's another one, product management supervision, or PMS. The product manager identifies a feature. The product manager tells the engineers to implement the feature, tracks the implementation of those features in the project, and the engineers write the code. First step, no bugs created. Second step, no bugs. Third step, no bugs. It's all looking good, and then the engineer writes the code bugs. All right, and then work hours is never ending, right? Whiner. Engineer writes the codes, creates some bugs. Engineers stay late to fix the bugs that they created, creating more bugs along the way. Engineers get tired and write even more code, creating many, many more bugs. And then the engineers sleep, no bugs.
So by now it should be pretty obvious that wherever there is code, there are bugs. So what can we do about it? Here's what we want. Remember, we saw that chart before. There are three potential solutions. The first one, we can make up the data. This is what we've done successfully many times. Works really well. You can also pay us to make up the data for you. You should really do that. Or you could fix your organization. And we're going to focus on the last one. We call that fixing the problem, or FTP. Chet didn't really like the acronym, so he came up with a better one, HERO.
It doesn't mean anything, but I like it as an acronym. Isn't that better? All right, so here's a typical engineering organization. You have managers managing teams of engineers who are the leaf nodes. They all have their workstations. They all connect over the intranet to some router, a series of routers in the company, and that talks to the internet. So they work on all their code, type, check it in, integrate with each other, and then ship it off to the real world, right? Well, if they're creating bugs and pushing it out to the real world, when maybe we should take steps to prevent that happening. The first step, obviously, is to prevent access to the internet. So if they can't push the product, it won't be a problem, right? Turns out engineers are really clever at getting to the internet. All they did was go downstairs to the cafe and just submit it on the free Wi-Fi down there. Right?
So the next step is to get rid of the intranet, the network, so the engineers cannot talk to each other. Unfortunately, some discovered that they could be social instead and just get up and go talk to the other engineers. So we decided to get rid of the workstations. That way they can't write code anymore. The next obvious step is, of course, to get rid of the engineers.
And that fixed the problem. It turns out that if you don't have engineers, no code gets written, no bugs are created. So this results in some of the processes that we think will work for you.
So here's one. Hire more managers. Or So let's look at why it works. So here are things that managers do. Managers manage people. They do not write code.
Managers attend meetings. They don't write code.
They talk with other managers, but they do not write code.
Managers facilitate cross-functional growth strategies and interdepartmental team facilitation for the purposes of collaborative interfacing and departmental-wide coordination. They do not create bugs. All right? So some of you in the audience are probably wondering, whoa, we have products. And we need to get revenue from those products in order to keep the companies around. So what are we going to do about this? What about sales?
Or was. So you have the first version of your application, release 1.0, everything's fine, you ship it. Then you ship release 1.1 with new features, which means you ship it with new bugs. There are more bugs. And then you keep doing that. You have release 2.0, comes out with more bugs, 2.1, more bugs, 2.2, more bugs, 2.3, more bugs. And that's when you achieve the corporate realization or company knowledge, or what we call CROC. And this is a very subtle way of fixing the issue. You take release 2.3, and then you reship it as release 3.0. You can sell it again, but you didn't add anything, so there are no new bugs. And then you can keep doing this. Release 3.1 is just release 2.3 again and again and again, so you do not need engineers anymore.
As long as you tell people that they're getting new capabilities, they won't actually know. Software is really, really complicated, isn't it?
And you can see that these days when you go on the App Store or the Google Play Store, every new release of every app says bug fixes and improvements. That's why.
So for everybody that's an engineer in the audience, I'm sure you're wondering the other part. Well, what about engineering or we? So if you're talking about eliminating engineers from organizations, then what's going to happen to you? Right? So we'd like to point out that, well, you're not doing any more coding, which means you're not creating more bugs, which means that you are single-handedly creating more quality in the product of your company, which means you're developing expertise in quality, which means that you have now become an expert in quality, which means that now you too can give presentations on quality just like this one. And now we have time for Q&A.